this video, we'll see how to make a tiny, simple game that runs directly in your terminal. The game is built using plain C#, and the only prerequisites are having the .NET SDK installed, find the link in the description, some basic programming knowledge, and your favorite IDE configured to build and run C# code. That's all. The game will have a Sokoban-like style. Sokoban is a puzzle video game created in 1982 in which the player can push boxes around in a warehouse trying to get them to storage locations. In our case, to keep the game simple, we will include the possibility to push the boxes, but to win the game, the player will just have to collect a certain amount of money. To design the game using a terminal, we will draw a grid of characters where each character will identify a different game element. We'll have characters for the walls of the storage room, tiles, boxes, the player, and so on. To simulate the player moving around pushing boxes, we can calculate the new positions and redraw the whole grid with updated characters. This way we can give an impression of movement. And now, let's dive into the code. Let's start with some standard C# console application code, where we add a while loop that keeps our application running until we decide to stop it, and some global variables with our grid, number of columns and rows, something to keep track of the collected coins, and the characters representing the different game elements. Let's dive into the run function. In this function we will instantiate and populate the grid with initial characters, basically two nested for loops where we set walls and tiles characters. We'll then place coins and boxes in random positions within the grid boundaries, place the player, and build another infinite while loop. This loop will allow us to intercept the user input, to move the player and redraw the grid with the new positions. We'll also check if our winning condition is met, but we'll talk about it later. Last but not least is the move function. The function receives x and y values plus reference to the grid we need to update. X and Y identify the direction of movement on imaginary axis. X equals 0 and Y equals 1 means going up. X equals 1 and Y equals 0 means right, and so on. This way we are able to calculate the next player position by adding the direction to the current position. Next, we make sure we don't cross the grid boundaries, and then we can start evaluating what we'll find in the next position. If it's an obstacle, we have to move it, of course, or at least we try, but before we move it, we need to make sure we are not moving it on a coin or another obstacle. If the destination is free, then we can move the obstacle or at least simulate a movement. We do this by setting the destination cell in the grid to the obstacle character. Simple as that. On the next cycle, in our while loop, the grid will be redrawn with all the positions updated, and it will look like the obstacle got moved. Alright, that was the obstacle. Now back to the player. Make sure we increase the coin counter in case the player's destination contains 1. After all that, we can safely set the player's starting position to a simple tile, and the destination to the player character. Make sure you update the player reference with the new position at the end. Let's go back to the run function. Remember that we designed the function to return a boolean. This will allow us to control the lifecycle of the game. When we return false, the flow will exit the main while loop inside the main function. Otherwise, the whole run function will restart, allowing the player to play a new game. The last bits we need to take a look at are the winning condition and further keys the player can press to control the game flow. When the coins counter reaches the total number of placed coins, the game is finished, and the player can choose to restart the game or exit by returning true or false based on the pressed key. On the same note, the player can press R or escape at any time during the game, and this will produce the effect we mentioned before. And that was all for this video. The source code can be found on GitHub. I'll leave the link in the description. Remember that this code is just for demonstration purposes and it's not meant to be used in a professional environment. Also, play with infinite loops very carefully because it's easy to forget the exit condition and that will cause the application to get stuck indefinitely. I hope you enjoyed the video and see you in the next one.